If you run Pi-hole or Pi-hole plus Unbound within your home network, and at the same time, if you configure VLANs, you may encounter issues when it comes to DNS domain name resolution. In this video, let's talk about how we can resolve that. By the way, this video is not really related to Unbound, but just because a while ago I posted a video about Pi-hole plus Unbound plus DOT, I want to continue the discussion. That's why in the title of this video, I have Unbound. In this video, I'm going to use Ubiquiti UniFi network devices as example. In my lab environment, within one machine, I configured both Pi-hole and Unbound. And this machine is running within VLAN 1. In the lower part, you can see I have 3 VLANs just to demonstrate a typical VLAN setup. VLAN 1, which is default, and the VLAN 10, which is insecure for IoT devices. And I also have a admin VLAN. You can see from the different colors of the arrows. For default VLAN, it can access IoT, but not admin VLAN. For admin VLAN, it can access both the other VLANs, but for IoT VLAN, it cannot access the default and admin VLANs. This type of requirements are typical within home network. I'm going to discuss 2 different ways to achieve what we want to use Pi-hole among multiple VLANs. First, change our firewall rules and configure the Pi-hole so that Pi-hole at this IP address can serve multiple VLANs. The second approach, let's make Pi-hole serve the DNS services in every single VLAN individually without changing any firewall rules. This is the screen layout I'm going to use for this video. In the upper right, I have UniFi network controller and the Pi-hole machines. In the lower part, I have 3 Linux clients. Each one resides in an individual VLAN. Let's check the current configurations. So let me go to UniFi network controller. Go to settings. For network settings, you can see I have 3 network defined, the VLAN 1, 10, and 20. For each one of them, let me take admin as an example. Of course, the subnet is 20. If I scroll down to the DHCP service management, then I can find the DNS server configuration. At this moment, I have not pointed to the Pi-hole yet. It's pointing to external DNS server. So for the other VLANs, I have similar configuration when it comes to DNS at this moment. If I check the current firewall rules, go to security, you can see I follow the drop off first methodology. I have a drop inter VLAN rule defined in the very beginning. I only allow the traffics which I want. If we check the diagram side by side, you can see all the red disallowed directions. They are achieved by this drop all rule, right? And then for each single green ones, I created corresponding rule. For example, allow admin to IoT. For example, allow default to IoT. So then move to the right. Let's check Pi-hole. If I go to settings for DNS, you can see it's not pointing to external upstream DNS server. Instead, it's pointing to the local machine with this port number. This is for my Unbound server. My Unbound server is pointing to external DNS servers. At this moment, the Pi-hole machine is ready to be used as DNS server, even though we haven't used it yet. Let's see at this moment, what's the situation for the 3 VLANs. Move to the default VLAN first. In the diagram, I also indicated the individual IP address for each Linux machine. So from default VLAN, let me see whether I'm able to access admin. No, I cannot. Correct. And move on to IoT VLAN. Let me see whether I'm able to access default VLAN. No, I cannot. Correct. And then from admin VLAN, whether I'm able to access default VLAN. Yes, I'm able to do that. What about the IoT VLAN? Okay, no problem, right? The firewall rules work. But let's see whether they are able to access internet. Ping abc.com. Yes. From default VLAN, no problem. From IoT VLAN, no problem. From admin VLAN, no problem. So everything is expected because at this moment we are not using Pi-hole yet. What if now we point the DNS server to Pi-hole? What will happen? Go to UniFi network controller. For network setting, let me start with default VLAN. Go to the DHCP service management. For DNS, change it to my Pi-hole server's IP address. Apply changes. Then quickly do the same thing for the other VLANs. Before we start testing the DNS domain name resolving again, we need to refresh the DHCP configuration in each Linux client. Otherwise, the DNS server change won't be effective. So let me do it. Okay, done. From the default VLAN, let me do the same thing. Ping abc.com. Okay, no problem. That's expected because the Pi-hole server itself is also in the default VLAN, right? There's no reason why this doesn't work for default VLAN. But what about IoT VLAN? It's just hang there. That means the packets were dropped. There's no response from the DNS server. It failed. For the admin VLAN, the same thing happened. So only the default VLAN works. Let's check the diagram. So the root causes for the IoT VLAN and the admin VLAN are not really the same. Let's talk about admin VLAN first. Yes, from the firewall rules, the admin VLAN is able to access the other two VLANs, right? Theoretically, it should be able to access the Pi-hole server. Why we have failure in the DNS name resolving? And the second thing is for the IoT VLAN. No matter whether the Pi-hole server works or not, from IoT VLAN, we simply cannot reach out to any machine in the default VLAN because of our firewall rule. So we need to resolve the firewall first. Then we talk about the Pi-hole server. Let's resolve the issues starting from IoT VLAN. Let's work on the firewall rule first. So let me go to the IoT Linux. Instead of pinging abc.com, let me dig the domain name. It will hang there for a moment. Then return error. Communication error to this IP address. What's this? This is the Pi-hole IP address we set in UniFi network controller for this IoT VLAN. Because we have the firewall rule, so this machine cannot reach out to the machine in default VLAN. That makes sense. But how we can change firewall rule to open up this access is very simple. So let me go to firewall rules in UDM Pro. I want to create a new entry, allow access to Pi-hole DNS. For protocol, I only want to allow UDP because that's what DNS service will use. For the source type, I already have a IP group defined previously. This is the RFC 1918 subnets, which means my local network, including all my local VLANs. So I don't care which VLAN as long as it's my local network. I want it to be included in this firewall rule. And the port group, I don't care. Then about destination, for destination type, I only want the access to be the Pi-hole machine. So I already defined a IP group for the Pi-hole. It's very simple. I don't want to waste your time here. I will directly select it. See here, Pi-hole. Basically, this means this one single .1.88 machine. And that's not enough because I don't really want the other VLANs to access these Pi-hole servers any other services. I want to limit the access even more. For port group, I only want to allow the DNS part. For this firewall rule, I open up access to the Pi-hole machine to the DNS service only. Add rule, let me change the sequence for this new firewall rule. I will move it to the very top so that it will be processed first. Okay, that's it. That's our simple firewall rule. In the IoT Linux machine, let me try to dig the abc.com again. It seems it still doesn't work. Yeah, you can see timeout. Even though we already enabled the access to Pi-hole, when it comes to DNS service, we got the same error. That's strange. Let's try the same thing in the admin VLAN. According to the firewall rules, we allowed full access from this admin Linux machine to Pi-hole, right? So let me see whether it can get the IP address back. Let me do the same thing. Dig abc.com. Too bad we get the exact same error. That means it's not just because of firewall rules. There are some more fundamental things we are missing, right? What will that be? It is within Pi-hole configuration. In Pi-hole, go to settings, go to DNS, scroll down. There's this very strange setting. You may not be able to understand what this means exactly, but this is our root cause for other VLANs to be unable to access the Pi-hole DNS service. By default, Pi-hole only allow the local request. Local means the same VLAN. So that means it only allows the .1 subnet to access its service. We have the three possible options. I don't want to spend time explaining the exact differences. If you are interested, you can go to Pi-hole documentation, check the interfaces document. So for this video, we simply enable this one. We allow the Pi-hole to respond to this interface, regardless from which VLAN the request is from. It will serve other VLANs as well. Once we make the change, save it. Now it's active. Let's try the IoT Linux machine again. Let me do the same thing. Dig abc.com. It immediately returned with the correct result. And for admin VLAN, the same thing. Yeah, same result. Problem is resolved. Let me summarize. In this approach, we did two different things. If you do have firewall rules which prevent your computers from accessing the VLAN which Pi-hole server resides, you need to create firewall rules to open up that access. But that's not enough. You need to furtherly configure Pi-hole to allow it serves other VLANs instead of just the local VLAN. Some people may not like it because it requires we open up access from other VLANs to this particular Pi-hole machine to the DNS service. See these three green arrows? That's required to allow this approach to work. Some people may not like it. They don't like to mess up with the firewall rules. Before proceeding, we need to revert back the firewall rule changes. Delete this additional firewall rule we added in the first approach. In the first approach we just talked about, because the Pi-hole server resides within this .1 subnet or VLAN default, to allow machines in other VLANs to be even able to connect to Pi-hole, we need to manipulate the firewall rules, right? Apparently, the idea for the second approach is why not provide DNS services in each single VLAN. So then we don't need to touch the firewall rules. We even don't need to touch the Pi-hole configurations. We simply need to work on the operating system's network configurations. Let's do that. We have three VLANs, three different subnets. The idea is for each subnet on this server for Pi-hole, I have a distinct interface so that the Pi-hole can provide DNS resolving service on each subnet. This Pi-hole server you see here is a brand new Pi-hole server. It's not the one we used in the first approach. So you can see from this icon, it's managed by Linux Network Manager. And if we go to the network setting, we can see currently its IP address is .1.99. It's in the default VLAN. There's no other network interfaces. Okay, so this is the default current Pi-hole server network configuration. And if we go to the settings, remember in the first approach for DNS, we changed the setting for the interface, but you can see here for this default configuration for the brand new Pi-hole, it has the default setting, allow only local request. We don't want to touch this setting. We don't even want to touch any configuration for Pi-hole. Depending on the operating system, you run your Pi-hole. In my case, I run it on Debian. So what I need to do is on Debian, I want to manually configure my network using the configuration file. Before the configuration, I need to know my network interface name. Depending on the hardware in your system, the interface name may be different. To easily find it out, let me see what's the current configuration. Okay, it tells me the interface name, ENS192. In the Pi-hole server's Linux, let me edit a network configuration file. It's under etc network, and the file name is interfaces. By default, the file is pretty simple. Let me add my new interfaces in the end. Okay, this part is the one I just added. So basically what I want to say is in the first section, I want to add a new interface with this name, and it's a static IP address configuration. And with this IP address, I choose a IP address which is different than the previous approach on purpose. And then the 24 indicate the subnet mask. For gateway, this is my UDM Pro's IP address for default VLAN. Then the second section is for VLAN 10 for the IoT VLAN. This is the interface name with special naming convention, dot, and then the VLAN ID. For IP address, it's 10.98. The gateway is the corresponding UDM Pro's IP address. Similar way for VLAN 20, this is the configuration. So you can see pretty simple, straightforward network configuration, right? Write the file, then exist. To make it effective, we either restart the network manager or I simply reboot the Linux machine. While it's rebooting, let me explain an additional thing. Because I'm running this Linux on a ESXi server, so it's a Linux virtual machine. To enable the VLAN trunk, I need to do some special configuration on the ESXi level. This is the port group used by my Linux virtual machine. If you check the setting, you can see I set the VLAN ID to this number. This number indicates I want to enable VLAN trunk. If you happen to use ESXi, you may want to do similar thing, but if you run your Linux in different way, it's not relevant to you. Okay, let me go back to the rebooted Pi-hole server. Okay, the operating system has been rebooted. You can immediately notice one difference is this icon for network configuration. Now it's showing question mark. Why? Because network controller for Linux cannot determine the IP configuration anymore because we manually changed the configuration file, right? To validate the current effective one, let me simply run this command. Yes, we can see this interface for default VLAN, this one for VLAN 10, this one for VLAN 20. From the operating system level, we are good. Remember, we haven't changed anything in Pi-hole, right? To finish the change, we need to go to UDM Pro to change the DHCP settings for each VLAN. To save time, I already completed the change. Let me quickly show you. For default VLAN, you can see this is the DNS server I configured. In the right side, we have the same IP address. Then for VLAN 10, we have this DNS server. In the right side, you can find the same information. For VLAN 20, we have similar thing, right? I don't want to waste your time. So we are done with all the needed configurations. Now let's validate it. Before we can even test anything, remember we just changed the DHCP settings in UDM Pro, right? We haven't refreshed the client setting yet. We need to do that. Let me quickly do it. Okay, now let me start with the default VLAN, digx.com. Okay, I quickly get answer back, and this is from the newly configured DNS server. No problem, we are good. Of course, this is default VLAN. We expect it to work, right? Now the moment of truth for IoT VLAN, VLAN 10, digx.com as well. Okay, we got answer back quickly. This time it's from this IP address. You can validate from the Pi-hole as well. It's the one we configured for the VLAN 10 on the operating system level. Good. Let's validate VLAN 20. Okay, similar thing from this Pi-hole server. So we are all good. As you can see, I really like the second approach because it only involves configuration changes on the Linux operating system level. And we don't need to mess up the router's firewall settings. We don't need to change Pi-hole's configurations. This is the end of the video. Thanks for watching.